Good evening everyone, my name is Raghavendra DL and I am studying in the East West College of Engineering. Today my topic is OLED technology. What is OLED? It is an organic light emitting diode. A light emitting diode containing a thin flexible sheets of an organic electroluminescent material used mainly in the digital display screens and emerging technologies for displaying the devices. The main principle behind the OLED technology is electroluminescence. What is electroluminescence? The emission of a light by a phosphorus when activated by an alternating field or by a gas when activated electric discharge. It offers brighter, thinner, high contrast and flexible displays. Next we see what is an OLED. OLEDs are the solid state devices composed of a thin films of an organic molecule that is 100 to 500 nanometers thick. The OLEDs are the simple solid state devices comprised of a very thin films of an organic components in a electroluminescent layer. These organic components have a special property of creating a light when electricity is applied to it. The organic components are designed to be in between the two electrodes. Out of this, one of the electrodes should be transparent. The result is a very bright and crisp display with a power consumption lesser than the usually LCD and the LED. They doesn't require any backlight, that is they are self-emitting. They are made from the carbon and the hydrogen. Next we see the features of an OLED. The first feature is an flexibility. A flexible OLED is based on the flexible substrate which can be either be plastic, metal or the flexible glasses. Next, emissive technology. What is emissive technology? The heart of the device and where the light is made, the emissive layer consists of a color defining the emitter doped into a host. This emissive technology consists of two layers, namely blocking layer and the electrons transparent layer. That is blocking layer commonly used to improve the OLED technology by confining the electrons, that is charge carriers, to the MSP layer. Next we see the blocking layer common supports the transparent of an electron across its so they can reach the MSP layer. It is light in weight and thin. It consumes the less power and it has a high contrast, brighter and perfect display from all the angles. Next we see the structure of an OLED. The structure of an OLED consists of cathode, MSP layer, that is organic molecules or the polymers. Next, conducting layer, that is organic molecules or the polymers. Next, anode and the substrate. First we see the cathode, that is transparent or not injects electrons when the current flows through the device. Next, conducting layer, that is transport from holes from the anode. What is anode? Transport add the electrons holes when a current flows through the devices. Next, organic semiconductor, conducting and emission layer made of an organic molecules. Next, emission layer made from the different organic plastic molecules composed to conductive layer, that is transparent electrons from the cathode. That is light is created in this layer. Next we see the substrate. Clear plastic, glass or an OLED have more than two layers, that is blue and green emitting layers for generating the resolution. Next we see an OLED fabrication, that is substrate preparation. Substrate preparation, it is arranged on the luminous material layer in the first opening. Next, device deposition, deposit and the pattern anode, pattern organic layer and vacuum deposit and the pattern cathode. Next, encapsulation. The use of the encapsulation layer is a fundamental for the device of production and to ensure the required lifetime, since the OLED material shows the sensitivity to the oxygen and the moisture. It also involves making the black plane. Next, we see the OLED deposition. The organic layer can be applied to the substrate using the following methods, that is evaporation and the shadow masking. Next, inject printing. Evaporation and the shadow masking, the organic light emitting diodes flat panel display the passive matrix micro fabrication integrated shadow mask small molecules polymorphism. Next we see the inject printing. The printed layer of the thickness can be controlled in a reproducible way. Working the devices with an injected printed layers can be made having the normal efficiency. It is difficult to control the recrystallization in the multi-layers system. Next we see the organic vapor phase deposition. This is also an efficient technique which can be carried out at the low cost. A cooled substrate is being hit by an organic molecule which was evaporated in the low pressure of an high temperature chamber. The gas is carried out onto the substrate with the help of the carrier gas. Next, we see the color generation. Different approaches for the fabrication, that is red, green and the blue pixel. The red, green and the blue are the individual pixel. That is white emitter and the white emitter and color filter, and the blue emitter and the color converter. Next, stacked OLED. Next, we see the working principle of an OLED. When the power is switched on, the cathode, that is the negative terminal, starts receiving the electrons from the power source, and the anode, that is the positive terminal, start losing them. As a result of this, the emission layer which is adjacent to the cathode, the starts becoming more negatively charged due to the increase in the supply of the electrons, and the conductivity layer becomes more positively charged, that is more holes. OLED works in the similar way to the conventional diodes and the LEDs, but instead of using the layer of an N-type and a P-type semiconductor, they use an organic molecule to produce their electrons and the holes. A simple OLED is made up of 6 different layers. The top layer is called the seal and the bottom layer is the substrate. In between those layers, there is a negative terminal. Sometimes it is called as a cathode, and the positive terminal it is called as a anode. Finally, in between the anode and the cathode are the 2 layers made from the organic molecules called the MSP layer, where the light is produced, which is next to the cathode, and the conductive layer which is next to the anode. Since positively charged particles, that is holes, are more mobile than the electrons, they crosses over to the MSP layer. Even time holes bump into the electrons. Quick bursts of the energies are released in the form of the photons, that is fundamental particles of a light, that is light is produced. The momentum you pull the plug on the power supply, the transfer stops instantly and the screen goes dark. Next, OLED advantages: thinner, lighter and the more flexible, do not require a backlighting like a LCD, can be made to the larger size, larger fields of the view about 170 degrees, faster response time, brighter and a high resolution. Next, we see the disadvantages of the OLED: expensive, lifespan, water damage, color balance issues. Next, we see the application, that is major applications of an OLED technologies are OLED TV, mobile phones with an OLED screens, roll laptops. Next, conclusion: organic light emitting diodes are the evolving as a next generation display. As OLED display technology matures, it will be in a better able to improve upon the certain extents limitations of an LCD, including high power consumption, limited viewing angles, poor contrasts and the ratios.